Welcome everyone. In this video we're going to explore graphing linear equations. We're going to break this lesson into 5 short and focused parts. Part 1, Intercepts and Slopes. Part 2, Types of Slope. Part 3, Slope-intercept form. Part 4, Determining the slope. Part 5, Graphing lines. Let's get started. Let's start with 2 big ideas that help us graph any line. Intercepts and slope. An intercept is where a line touches one of the axes. There are 2 kinds, the y-intercept and the x-intercept. The y-intercept is where the line hits the y-axis. At this point, x is always 0, because we are on the vertical axis. So the point looks like 0, y. The x-intercept is where the line hits the x-axis. Here, y is 0, because we're on the horizontal axis. So the point looks like x, 0. Intercepts are helpful because with just these 2 points, we can already sketch a line. Slope tells us how steep a line is, basically how quickly it goes up or down. If a line is straight, the slope stays the same the whole way. We find slope by comparing how much the line rises or falls compared to how far it moves sideways. A simple way to think about slope is, slope equals rise divided by run, or slope equals how much y changes divided by how much x changes. We'll look at different types of slope in the next part. Now let's look at some graphs to actually see intercepts and slope in action. On the graph on the left, we have a line with a positive slope, that means it goes up as we move left to right. First, notice where the line crosses the y-axis. Right here, this is the y-intercept. This point always has an x value of 0. Next, look at where the line crosses the x-axis. That point is called the x-intercept, and its y value is always 0. Now let's talk slope. To find the slope, we can follow the green steps, the rise and the run. We go up a certain amount, that's the rise. And then we go right, that's the run. Since the line is going uphill, the slope is positive. On the graph on the right, we see the opposite, a line with a negative slope. This one goes downhill as we move left to right. Again, look where the line touches the y-axis, that's the y-intercept. Same idea, the x value is 0 at this point. And here is the x-intercept, where the line crosses the x-axis. Now look at the green slope triangle. This time, we move down as we move to the right. That down movement makes the slope negative. So positive slope rises, and negative slope falls. These examples help us see how intercepts and slope show up on a graph. Next, let's look at the different types of slopes we can have. Let's look at the 4 types of slope you'll see in linear graphs. Each one tells us how a line moves as we go from left to right. When a line has a positive slope, it goes uphill from left to right. That means as x increases, y also increases. We say the function is increasing. A negative slope is the opposite. The line goes downhill from left to right. As x increases, y decreases, the function is decreasing. A slope of 0 means the line is completely flat. There's no rising, no falling, it stays the same height the whole way across. That's why we call it a constant function. An undefined slope happens on a vertical line. This kind of line doesn't run left or right at all, so slope doesn't make sense here. Vertical lines always have an undefined slope. So now that we know all 4 types of slope, positive, negative, 0, and undefined, let's move on to the slope-intercept form of a linear equation. Now let's look at one of the most important forms of a linear equation, the slope-intercept form. The slope-intercept form tells us 2 key things about a line: its slope and its y-intercept. In this equation, the letter M represents the slope, that's how steep the line is and whether it's rising or falling. The letter B represents the y-intercept, that's the point where the line crosses the y-axis. This point will always look like 0, b, because the x value is 0. When you see an equation in this form, you can immediately tell how steep the line is, and exactly where to start graphing it. Now let's practice finding the slope and the y-intercept when we're given an equation that's already in slope-intercept form. Remember, in the equation, y equals mx plus b. The number in front of the x is the slope, and the number at the end is the y-intercept. In example A, the slope is the number multiplying x. Here, that number is -2/7, so our slope is m equals -2/7. The y-intercept is the number added at the end, which is +5. That means the y-intercept is the point, 0, 5. Now let's look at example B. The slope is the coefficient of x again, this time it's 3, so m equals 3. The y-intercept is +7, so the point is 0, 7. For example C, the slope is 7/8. That's the number attached to the x. The y-intercept is the constant at the end, here it is -3/5. So we write the y-intercept as the point, 0, -3/5. Now that we know what the slope-intercept form looks like and what each part means, let's practice finding the slope from a graph or from 2 points. Now let's practice finding the slope when we're given the graph of a line. Remember, slope is rise over run, how much the line goes up or down, divided by how much it goes left or right. On the graph on the left, the line is going upward as we move to the right. So this line has a positive slope. To find the slope, pick 2 points that land exactly on the grid. Starting at the lower point, count how far we go up to reach the next point. We go up 2 units, so the rise will be 2. Now count how far we go right to get to the same point horizontally. We move 1 unit to the right, so the run will be 1. This means the line goes up 2 units for every 1 unit we move to the right, therefore the slope is 2. On the graph on the right, the line is going down as we move to the right. That means this slope will be negative. We again pick 2 points that land exactly on the grid. Starting at the higher point, we move down 2 units to reach the lower point. Because we are moving down, the rise is -2. Now, from that point, we move right 3 units. So the run is 3. Using slope equals to rise over run, or vertical change over horizontal change, the slope is -2/3, or -2/3. Now that we found slope by looking at a graph, let's look at the formula we use when we're given 2 points instead. The slope of a line is always the change in y divided by the change in x. This matches what we've been counting on the graph, rise over run. Here is the slope formula. M equals rise over run. Which equals delta y over delta x. Which equals y2 minus y1 over x2 minus x1. This means we subtract the y values, and subtract the x values, and then divide. When you see delta y or y2, y, that just means how much did y change? And when you see delta x or x2, x, that means how much did x change? As long as the change in x isn't 0, the slope is well defined. This formula matches exactly what we did on the graph. We always take the difference in y values first, that's the rise. And then the difference in x values, that's the run. Next, we'll use this formula with actual points to practice calculating slope without needing the graph. Now let's practice finding the slope when we're given 2 points instead of a graph. We're going to use the slope formula. Slope or m is equal to rise over run, or change in y over change in x, which ultimately is subtracting the y values on top, then subtracting the x values on the bottom. Let's start with example A. Using the slope formula, the slope will be equal to -3 minus 8 over 2 minus -4. -3 minus 8 is -11. And 2 minus -4 is 6. So the slope is -11 over 6. In example B, notice how both points have the same x value, which is 2. Using the slope formula, this will become -4 minus 7 over 2 minus 2. This will result in -11 over 0. Since nothing cannot be divided by 0, the slope of this line is undefined. If the slope of a line is undefined, then it is a vertical line. For the last example, notice both points have the same y value, which is -3. Using the slope formula, gets -3 minus -3 over -2 minus 5, which results in 0 over -7. 0 divided by anything is 0, therefore the slope is 0. A slope of 0 means the line is perfectly flat. In this part, we're going to learn how to sketch a graph directly from an equation. We'll use the slope and the y-intercept to draw the line quickly and accurately. To graph a line, use the y-intercept as a starting point, then use the slope to plot more points. In the graph to the left. First, we plot the y-intercept at the point, 0, -1. Next, use the slope. Using slope equals to rise over run, and the fact that the slope is 3/5, means this line is increasing at a rate of 3 units vertically for every 5 units horizontally. In short, to find a new point, go up 3 units and write 5 units from the y-intercept. Another point can be found by going in the opposite direction from the y-intercept. In other words, another point can be found by going down 3 units, and left 5 units from the y-intercept. After finding the points, the last thing to do is draw a line connecting the points. In the graph to the right, follow the same steps to graph the line. Start by plotting a point at the y-intercept, where x is 0 and y is -2. Then use slope equals to rise over run to state the slope of 3, and that 3 can be written as 3 over 1. Next, count 3 spaces up and 1 space to the right. This can be repeated again to find the point. Another point can be found by reversing the direction. That is by going down 3 spaces, and left 1 space. Once the points have been plotted, draw a line connecting the points. So when graphing a linear equation, remember. Start at the y-intercept, then use the slope to move to another point. 2 points are all you need to make an accurate graph. Now let's graph a line when we're given 1 point on the line and the slope. This is really useful when the equation is not in slope-intercept form, or when we're only given scattered information. Our first step is to plot the point we're given, -1, 5, as this point is already on the line we want to draw. Next, we use the slope to move from this point and find other points on the line. Given that the slope is -5/3, means the rise is -5, so we move down 5 units. The run is 3, so we move right 3 units. So going down 5, right 3, that gives us another point. And going down another 5 and right another 3 units would give another point. Finish the problem by drawing a line running through the points. For our final example, let's work backwards. Instead of starting with an equation and drawing the graph, we're going to look at the graph and write the equation of the line. First, find the perfect points on the graph, or points that land exactly on grid intersections. I'll use the y-axis point, 0, -1, and the point at, -3, 0. Now count how many spaces the graph goes down and to the right. In this graph the points are 1 down and 3 to the right from each other. So the slope is -1/3. Next, by drawing a line down the y-axis we can see that the y-intercept is at 0, -1. Next, find the x-intercept, which is where the line touches the x-axis. Here the graph touches the x-axis at -3, 0. So in the end, the slope is -1/3. The y-intercept is 0, -1. And the x-intercept is -3, 0. In part B, to write an equation that defines f, we will substitute y for f of x. Since the slope is -1/3, and the y-intercept is at 0, -1, instead of being y equals to -1/3 x minus 1. The equation will be f of x is equal to -1/3 x minus 1. Awesome work today! You learned how to find slope, intercepts, and how to graph lines from an equation or a point. That's a huge step in understanding linear functions. This wraps up video 1. In the next video, we'll dive into writing equations of lines. See you next time.